Hello, viewers. In today's session, we are going to discuss an important and very fundamental definite integral involving the greatest integer function, right? So here we are going to evaluate this integral that is from -1 to 2, and here we have sine inverse of greatest integer of 2x minus 1 over 3 dx, right? So this problem is going to be very useful and very beneficial for the beginners, right? So let us start. So let us take this integral as I, right? Now here we can solve this integral by two methods. The first one is by the method of inequalities, and the second one is by method of substitution, right? And we can also use the principal value branch of sine inverse function, which is from minus pi by 2 to pi by 2, right? But here in this class we'll prefer only the substitution method, right? So let us substitute here. T is equal to 2x minus 1 over 3. So we'll make the substitution. T is equal to 2x minus 1 over 3, so that we can write 3 times t is equal to 2x minus 1. So 2x is 3t plus 1. Then we have x is equal to 3t over 2 plus half, right? So now let us differentiate x with respect to t. So we have dx over dt is equal to 3 by 2, because the derivative of t with respect to t is 1 and the derivative of half is 0. So we have simply 3 by 2, so that we have dx is equal to 3 by 2 times dt, right? Okay, now let us change the limits. So here the lower limit is -1 and the upper limit is 2. So when x is -1, then the value of t may be obtained from this relation. So we have t is equal to 2 times -1 minus 1 over 3. So this is -2 minus 1 over 3, that is -3 over 3, that is -1, right? And when x is equal to 2, then the value of t is 2 times 2 minus 1 over 3. Here we'll take x is equal to 2. So now we have 4 minus 1 over 3, that is 3 over 3, that is 1, right? So when x goes from -1 to 2, t varies from -1 to 1, right? So let us rewrite this integral I in terms of t. So we have here -1 to 1, because the t varies from -1 to 1, and we have sine inverse of greatest integer of 2x minus 1. 2x minus 1 over 3 is t. So here we have greatest integer of t, and for dx we can write this expression, that is 3 by 2 dt. So now we can take 3 by 2 outside the integral, and we have -1 to 1 sine inverse greatest integer of t, right? Okay, so now we have to evaluate this integral. Now see, whenever we come across with the greatest integer function, our prime objective is to search for integers, right? So here the variable t, it goes from -1 to 1, right? And we can easily see that between -1 and 1 we have the only one integer, that is 0. So what we will do here, will break this integral into two parts. The first one is from -1 to 0, and the second one is from 0 to 1. So we have -1 to 0, sine inverse greatest integer of t dt, and then we have 0 to 1 and sine inverse greatest integer of t dt, right? Okay, now let us take these two integrals one by one. So let us first consider this one. Now here t goes from -1 to 0, right? So when t goes from -1 to 0, then the greatest integer of t should be equal to -1. So when t lies between -1 and 0, then greatest integer of t is -1. And when t lies between 0 and 1, then we have greatest integer of t as 0, right? So let us take greatest integer of t as -1 over here and 0 over here. So now I is 3 by 2, and we have -1 to 0 sine inverse of -1 dt, and the second integral is from 0 to 1, and we have sine inverse of 0, and here we have dt. So now from here we can see that sine inverse of -1 is given by minus sine inverse of 1, that is minus pi by 2, right? Because sine pi by 2 is equal to 1, right? So sine inverse of -1 is negative pi by 2. So here we have now I is equal to 3 by 2, and here we have -1 to 0, and here we have minus pi by 2 dt, and this integral is 0, right? Because sine inverse 0 is equal to 0. So this integral disappears here. So here we have 0. So now we have 3 by 2 times, here we have minus pi by 2, and then we have -1 to 0 dt, right? So now we can write I is equal to minus 3 pi by 4, multiplying these two quantities, and here the integral dt is simply t, and limits are from -1 to 0, right? So we can now write I is equal to minus 3 pi by 4, and now substituting the limits and taking the difference, we have 0 minus -1. So this is minus 3 pi by 4, and this is minus minus plus, so this is 0 plus 1, right? So I is equal to minus 3 pi by 4 times 1, that is equal to minus 3 pi by 4, right? So the value of this integral is equal to minus 3 pi by 4.